Okay, so we've just started talking about how we describe our data, and the chapter before we looked at how to calculate the centre or which centre to pick. And now we're going to look at one of our other ways of describing the data is to record or mention the measures of spread. This is also, you might want to write how the data varies. So, if they say one is more variable than the other, that means it's got a larger range. So the numbers are ranging larger. So we can use the simple range, which is just the maximum value minus the minimum. But this one here, you need to write it'll be affected by outliers. So because an outlier will be a minimum or a maximum value. So this one's affected by outliers, so maybe not always as good, but we can use it. So if we look here, sorry about this bit, I don't know why that's there. But if we look here and it says consider the marks for two different tasks awarded to the group of students, find the range of each distribution. So if we look at task A, so we know the range equals the maximum minus the minimum. So in task A, the highest number was 94 and the smallest number was a 2. So we had a range of 92. In task B, we had a range, so once again, the maximum, the biggest, minus the minimum. So in this one, it'd be 91 minus 11. So we end up with a range of 80. So because of that, we could make a statement if we were looking at the spread of these ones. We would say that task A is more variable. Yeah, because it ranges maybe with a larger spread. Of 92 compared to task B 80. Okay, so that's just, we're trying to get used to the language we might see when they're talking about the range and things like that. All right, so now we are just looking at these types of data here. So if we have a stem and leaf plot and we're asked to find the range, obviously this number here is the minimum and this number here is the maximum. Now be careful, make sure you're reading your key. So if I was doing the range of this one, so let's always write the rule out so we can show the examiner what we're talking about. Now the key says that the leaf is a decimal place, or a point. So the maximum was 6.4 and the minimum was 0.5. So we've got a range of 5.9. I just want to point out there's a fault in this stem and leaf plot. So the fault is the stem 1 missing. It should have the stem 1 there because it's going up in order, isn't it? Tens. So the 1, there should be a 1 in here with no leaves, but it should be there. Okay, so just be careful with that. With this next one, if you get a histogram and this is all you're given, the way you're going to work out if you get asked what the range is, so you know the range is the maximum minus the minimum. So if you're given a histogram, all you need to do is pick where the largest goes up to. So it's going up to 187 there. So the maximum was 187 and the lowest value looks like it's, I'm just going to say the lowest one was there, 173. Okay, so we've got a range of 14 there. Okay, so all the values ranged between 14 degrees there. Okay, so where the range, remember I said it's not good when we have outliers. So what we do is we go to the interquartile range, and that's our resistant statistic. Remember what we said, and it's not affected by outliers, same as like the median. So what the IQR is, if you have like you've got your set of data, so say this was your data, and your median will be in the middle of it. What your Q1 is the first quarter mark. So if you lined it up from lowest up to highest, you would Q1 would be in the first quarter mark, and Q3 is the third quarter mark. So the interquartile range is Q3 minus Q1, and what it does, it tells us all the range of the data in here, which is actually going to be 50% of the data. So when we have 50%, we say it's the majority. So we're going to say, well, the majority lies between here and here, because that's the IQR. Okay, so when we are trying to find the interquartile range, we have to order the data. So the first thing, you've got to make sure that the data's all written out in lowest to highest. You divide it in half. So what you do is generally find the median and split the data in half. Okay, and how you find the Q1 is like you find the median of the first half, and the Q3 is we'll find the median of the second half. So we do the same steps as when we're finding the median. So let's give that a go. So here in this example, it says find the interquartile range of the weights of 19 cats. So the first thing we've got there, overall we know N was 19. Okay, so if you were finding where the median was, the median would have been found at N plus 1 divided by 2. So we would have said 19 plus 1 divided by 2. The median would have been the 10th value. So if you go in here and we find that, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that number 9 there is your median value. So I'm just going to rub out those numbers. So when we're going to go find the Q1, so the first half, okay, so here's our first half is here. All these numbers up to here. So if you counted up that, in our first half, we have the total N is actually, there's 9 values there in our first half. So the Q1 equals the median of the first half. So what we're going to do is we're going to do the N plus 1 divided by 2, but just with our new N number, which is 9. So we do 9 plus 1 divided by 2. So the Q1 is going to be the 5th value. So if you go 1, 2, 3, 4, 5, there it is. So 2.5. So Q1 equals 2.5. Now, because that's the first half, the second half is going to be the same size. So what I often do, so if you looked, the second half would have 9 numbers as well. So all I say, once you've found out what the Q1 one is, you can just do the same, but you just go for the Q3. It'd be the 5th value from the end. So we just count backwards and then we'll get it. So you go 1, 2, 3, 4, 5. So 4.8. So Q3 equals 4.8. Okay, so remember to read the key. So therefore, if we're trying to find the IQR equals Q3 minus Q1, we're going to have 4.8 minus 2.5, which equals 2.3. let's have a look at this one. The stem and leaf plot shows the life expectancy in years for 23 countries. So that told us what the original N was. So if we were finding the median of the whole data, remember the median would be at N plus 1 divided by 2. So 23 plus 1 divided by 2, so it would be the 12th. So if we go through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's my median. So the median was actually 73. Okay, so now I've split the data in half. I know that that is my median there. So once again, I'm going to take, sorry, I'll do it in the same color. We're going to take that first half. So if I've got 11 numbers in the first half before the median. So remember Q1 is the median of the first half. So the first half, we're going to say N equals 11. Yeah. So the Q1 is going to be found at N plus 1 divided by 2. So 11 plus 1 divided by 2. So it's going to be the 6th value. So if you go 1, 2, 3, 4, 5, 6. So Q1 was 66. Now remember Q3, I'm just going to go the 6th back from end because I've already worked that out. So I'll just go of the second half. So remember this is the second half, but you're going back from the end. So 1, 2, 3, 4, 5, 6. So Q3 equals 75. So therefore the IQR equals Q3 minus Q1, which equals 75 minus 66, which equals 9. Okay, so 50% of the data are within 9 years. So the life expectancy, it just ranges between, 50% of them range between 9 years. All right, so this next bit, standard deviation, just before we're going to go on to our calculators to have a little look. Standard deviation, first write on your calculator, it's written as SX on your calculator, and it tells you the measure of spread around the mean. So maybe put that symbol there. So because it only tells us the spread around the mean, we'll only use it in symmetric data. Okay, so you'll only see them talking about the standard deviation and spread around symmetric data, and we always use our calculator to calculate it. I've put the formula there, but you never have to individually do that. We're going to use our calculator. So I'm going to jump off and onto the calculator app.